So in the last session, we were discussing about up-down counter. Now, what is mean by up-down counter? Yes, what is mean by up-down counter?
It is combination of up counter and down counter.
Now, what is mean by up counter? Yes, Aishwarya, what is mean by up counter? Aishwarya,
Yes, yes.
what is mean by up counter? The circuit which counts pulses in the increasing order, that is a up counter, and the circuit which counts the pulses in a decrementing order, that is a down counter. Okay, so we are here making a combination of both these counters, that means up counter and down counter. So it will count uh, your pulses in an incremental order, or we can make that counter to count pulses in a decrementing order or decreasing order. So that is a up down counter. So for that, what we had, also we have provision that we can start from any number. Okay, so predefined number, we can start counting the pulses. So for that, in here, you can see that we have assigned input port, that is a num, which is a vector, or we can say it is a bus, which is of a 4-bit. Okay, so that means this counter will count 4-bit pulses. Okay, so that means it will count up to F 1111. Okay, so that pulses that could be counted by this counter. Okay, then we have a clock signal, that is the input port, then load signal, so that it could load this number. Okay, so for that purpose we have load signal, then reset signal, so that we can reset all this counter and then direction. So as we have two types of counters here, that is up counter and down counter. So to decide in which direction it is going to count the pulses, there is a port, that is the input port, and then we have output. Okay, so output port, that means it will output the whatever is the result of this program. Okay, so these are the different ports that we have, and then we have this port. Okay, so that is architecture. Already we have discussed about this code, but still we are going to discuss one more time about this code, and then we will discuss what was the error actually. Actually, this was giving us error, so that we are going to discuss. So here, we in our architecture, we have defined one signal, that is a temporary signal. So which is again a bus, okay, which is a 4-bit bus or 4-bit vector. So that is the temporary signal, TEMP signal, that we have defined here. Okay. And then in a architectural body, we have a process, defined a process which has the sensitivity parameters, that is a clock and reset. Okay. So depending on this clock signal and reset signal, it will execute all the instructions. So here, if reset is equal to 1, then temp will be equal to 0000. That means this temporary signal that will be having value, that is 0000. Otherwise, depending on the rising edge of the clock, if load is equal to 1, then we are going to load the number which is present at this port, that is a num port, to add to the temporary signal, that is a TMP. Okay? And if this load is equal to 0, then depending on the direction, we are going to count or calculate temp is equal to temp plus 1 or temp is equal to temp minus 1. So if direction is 0, that means dir signal is 0, then it is going to calculate temp is equal to temp plus 1. And if dir, that is the direction, is equal to 1, then temp will be equal to temp minus 1. Okay, so this is the architecture of this counter, up down counter. Okay, so here, after that, what we are going to do, whatever is the value of this temp, that we are going to assign to the output port. Okay, so now, as we have already saved this program, so let us check the syntax. And as you know that there is error in this syntax. So this was my question to you all, that what is the error in this course, and you need to tell me that error. What is the error in this code? So tell me error in this code. Meanwhile, I will take attendance here. So roll number one. Roll number one. Roll number two.
Present, ma'am.
Three.
Present, ma'am.
Four.
Present, ma'am.
Five.
Present.
Six.
Yes, ma'am.
Seven.
Present. Present.
Eight. Eight. Nine. 10.
Present.
11. 12.
Present.
13.
Present, ma'am.
14.
Yes, ma'am. Present, ma'am.
15.
Present.
16.
Present.
17.
Present, ma'am.
18.
Present.
19.
Present.
20.
Present.
21.
Present, madam.
22.
Present.
22. 23.
Present.
Present.
23. 24.
Present. Present, ma'am.
25.
Present, ma'am.
26. 26.
Present, ma'am.
27.
Present, ma'am.
28.
Present. Present, ma'am.
29.
Present, ma'am.
29. 30.
Present.
30. Okay. Okay. Remaining we will call afterwards. Okay. So now tell me, what is the error in this course? Okay. You can see here in this here you can see that there is a error, that is a uh, it minus cannot have such operands in this context, and then another error is that plus cannot have such operands in this context. Okay. So here is the error at line number 51 and 52. Okay, so here at these two lines there is a error. That means it is saying that this plus sign cannot be there in this context, as well as this minus sign should not be there. Okay, so it is error due to this. So can anybody tell me how to correct this error? Okay. And so I have given the hint that there is a correction that you should make at library declaration part.
मॅम अर्थ
So here is the error. Hmm? Yes.
आणखी एक हे ऍड करावं लागेल आपल्याला मग यूज लायब्ररी आय ट्रिपल ई एस टी डी
Yes.
लॉजिक
One
डॉट
package. Yes, we need to add one more package to this library because we are using certain arithmetic functions. Okay, and so for that we need to add one more package. This package that we have already added, that is std underscore logic underscore 1164. So that is for the common functions. Okay, but as we are doing it for the, that means it could be used for logical functions. But as we are going to use arithmetic function, so we need to add one more package. So we will add one package, that is a use I triple E dot, okay, std underscore logic underscore arith dot all. Okay, so that means all the functions which are present in this arith package that we are going to add to this library. Okay, now is it correct now whatever I have typed here? Whether the syntax is correct? What is needed? At the end of each statement in a VHDL, semicolon is needed. So this is, it should be added. Okay. Then after that, what as this VHDL is a case insensitive, so it is not going to affect whether I am going to type it in a lowercase or uppercase. So I'll keep it. Okay. Now is this much is sufficient?
मॅम आणखी एक पॅकेज ऍड करावं लागेल
Okay. So which one? Use IEEE. Okay. So IEEE package that we are
एस टी
going
डी
to add.
लॉजिक अनसाइन डॉट ऑल
Okay. So why we are going to add this package? Because we are going to perform arithmetic operations. So there it may happen that their numbers could be assigned numbers or unsigned numbers. So as we are going to deal with an unsigned number, so we are going to make it clear that we are going to use unsigned numbers, and so the whatever are the functions related with this unsigned numbers, so that functions we are going to add in this library. So for that we are going to add this package. Okay, so now I'll save this and let us check syntax. Okay, now you can find this that this process is completed successfully. Okay, so that means whatever is the syntax, that is correct. Okay, so let us check RTL schematic. So this is the RTL schematic, the pin diagram that you can see here. This is the bus, that is of a 4-bit. Okay, and this is again output bus, so which is also a 4. Okay, so here you can see this. Okay, if we click on this technology schematic, you will find this type of Okay, so this is the internal diagram of this up down counter. Okay, now let us close this, and for simulation purpose, as we need to have a test bench code, so we will write a test bench code. So right click on the project name, then click on the source type, that is a VHDL test bench that we are going to write, and then give the name to this test bench. So updown underscore counter underscore test bench. Okay, so this is the name that I am going to give to this source. There is certain error. Actually, I have simulated, I think. So this is the code. Sorry, that is. So again, here also we need to add those libraries. So we will add use IEEE dot std underscore logic underscore arith dot all. Also use IEEE dot std underscore logic underscore unsigned dot all. Okay. Now here you can see that whenever I have added these two packages, this looks in a pink color, but this one is a black in a black. Can anybody tell me why it is in a black color? Just look at this code.
मॅम IEEE नंतर डॉट येतोय तुम्ही अंडरस्कोर दिलं.
Yes. Okay. So that is the syntax error here you can see. So this should be a dot. Now here you can see this entity for this test bench. So it is there. Then architecture. Here we have not declared any port. We are going to call a component in this test code. So here there is no any ports declaration part in this entity. Okay. So now we are going to call a component here. So component that is called in a architecture, so or it is declared in this architecture. So component up down counter that we have declared here, and you can see all the ports that are assigned for this component. Okay, then initially we are going to assign the values to all the signals. So signal num, that is initially it is equal to 0, then clock that is also initially 0, and then reset that is made 0 initially. Okay, and then the direction that is also 0. Okay, so then port mapping for all these code, also clock period that has been defined here by default value, that is a 10 nanosecond, and we are going to keep that value as it is. Okay, then after that there is a clock process where we are going to assign a on time and off time of that clock. Okay, so we have considered 50% on time and 50% off time. That means 5 nanosecond on time and 5 nanosecond off time. And after that, we are going to have a stimulus process. That means we are going to assign the values to the inputs. Okay, so initially we have not made any changes in this initialization. Okay, so here we have kept a reset equal to 0, dir equal to 0, then load equal to 0, clock signal also equal to 0, and num is also equal to 0. So now what we are going to do, we are initially making reset equal to 1. Okay, so This will be made 1. Okay, now when we are assigning this value to the reset, that means 1 to reset, what will happen? Output will be equal to 0 0 0 0, because initially temp will be equal to 0 0, and we have made output that is equal to temp, so out temp will be equal to 0. Output will be also equal to 0 here. So now let us make this time period of 10 nanoseconds only. Okay. So after 10 nanoseconds, we are going to make reset equal to 0. Okay. Now when reset is equal to 0, depending on the value of load, it will take either the num value will be assigned to temp, or it will kept as a 0 0 0 0. So we will make load equal to, let me check first. When load is equal to 1, it will assign whatever values that are present for the num, that will be assigned to. Okay, so let us assign certain values for 1. So I'll take it as a 1010. Okay, then we will wait for 10 nanosecond again. Okay, and then we are going to make load equal to 0, and dir equal to 0. So what we did, we have made load equal to 0 and dir equal to 0. That means it will be acting like a up counter. Okay. Now whether this code is correct, just look at this code and tell me whether this is correct or not. What we have done, we have assigned certain values to each of the input port. Okay, and then we are going to check the output. But tell me whether this code is correct or not. Aarti? Okay. So till then, answer your roll call. 31, 31, 32,
Present, ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
35,
Present.
36, 36, 37,
Present, ma'am.
Present, ma'am.
38.
36 present, ma'am.
Okay. 38, 38, 39,
Present.
40,
Present, ma'am.
41, 41, 42,
Present.
43, 43,
Present.
44,
Yes, madam.
45, 45, 46, 47,
Present, madam.
48, 48,
Present.
49, 49, 50,
Present, madam.
51,
Present, ma'am.
52,
Yes, madam.
53, 53, 54, 55,
Present, ma'am.
56, 56, 57,
Yes, ma'am.
58,
Present, madam.
59,
Present, ma'am.
60, 60, 61,
Present, ma'am.
62, 63,
Yes, ma'am.
64, 65,
Present.
66,
Present, madam.
67,
Present, madam.
68,
Yes, ma'am.
69,
Yes, ma'am.
Ma'am, 11.
okay.
Hello, ma'am. One. Roll number
Huh?
1.
31, ma'am.
41, 31, okay.
Huh.
Roll number 8 is there? Mhm. So, what is the error in this code or whether it is correct code? Just look at the code. Okay. Now, I'll say that this code is not correct. Okay. So, do you tell me what is the error? आता मी तुम्हाला सांगितलं की हा कोड बरोबर नाहीये, चुकलंय याच्यामध्ये. असाइनमेंट ऑपरेटर्स आणि याच्यामध्ये एरर आहे, तर तुम्ही सांगायचं की कुठे एरर आहे. Shall I save this? Okay, no one is answering. That means this is a correct.
मॅम पहिल्या सेकंड रिसेट इज इक्वल टू 0 नंतरच त्या वेटच्या आधी हे दोन्ही स्टेटमेंट पण पाहिजे होते.
कुठले? ओके, इथे रिसेट इक्वल टू 0. ओके, पण त्यावेळेस आपला लोड तर काही असेल तर काही फरक पडणार नाही ना, 0 आहे तिथे आणि नम पण म्हणजे काही 0 आहे, ऑलरेडी असाइन केलाय पण 0 आहे. So that will not make much difference. But after here there is a syntax error. Okay, I'll save this and then you can find it. Okay, it is not showing any error. So let us go for the simulation. Okay, here. Now you can see. What is the error? You can see here, as this is a bus or the vector, so we need to initialize this value in a double quote. Okay, already I am telling this so many times that whenever it is a vector, you need to initialize it in a double quote, not in a single quote. Okay, so this should be in a double quote 1 0 1 0, and this should be quote should be completed. Okay, so let us save this and then let us go for this syntax checking. So this is correct. So let us simulate this. Clock is also not showing here. Can anybody tell me what is the error in this code? I could not. Okay. So, let me. Okay. So actually, that initialization was not needed in this test bench code. So that is why there was error. So initially, you can see here, this is the initially we have assigned the values that is a 0002 num. Okay, and after that we assigned the values that is a 1010. Okay, so that means your counting will start from 1010. Okay, as we have made this incremental counter, that is up counter, so it will count as a, for the next pulse it will count as a 1011, then next it will be 1100. Okay, so it will count up to 1111, and after that it will again count for the 0000. Okay, जेवढ्या pulses असतील त्याप्रमाणे तो count करत जाईल पुढे. ठीक आहे, so this is a up counter. Okay, now we'll make changes in this code so that it will be a down count. Okay, so just we will make this direction that is equal to 1. Okay, तेवढाच एक चेंज केला की आपल्याला काय मिळणार आहे, तो डाउन काउंटर मिळेल. So let us save this and again simulate. So here you can see that it will start from counting from 1010, then it is decremented to 1011, then 1000, 0111, then 1. Okay, so in that way it is a decreasing. तुम्ही बघू शकता इकडे. So 0011, then 0010, आणि हे कुठे चेंज होतो, जेव्हा प्रत्येक रायझिंग एज असेल क्लॉकची तिथे चेंज होतो आणि त्याप्रमाणे तुम्हाला काउंटिंग मिळतं. इथे 0001 and 0000. त्यानंतरच्या पल्सला तुम्हाला काय मिळणार आहे, काउंट 1111, आणि तो परत डिक्रीमेंट होते. So this is a down counter. So in a single program we have made a up counter as well as down counter. Okay, so remember that in this code, in a test bench code, no addition of that packages, that is arith and unsigned package, that is not needed. Okay, so as we have added that, but it was showing error in that result. Okay, so there is no need to add that packages in this test bench code. Okay, so remember that. So this is the code for the up down counter. Okay, so you need to write a report on this. Okay, so if you have any doubt you can ask. सगळ्यांना समजलंय का हे? Is there any doubt?